Sorry. Thank you to the whole team of Sonic Acts. So that's Annette, Lucas, Ari, Rosa, Hilde that we were working with. Yeah, it's been a really kind of an incredible kind of privilege to embark on an adventure with this group of people with their kind of highly sort of promiscuous imagination and all of the different encounters that they've helped to stage for us and to facilitate. And so it's a really kind of extraordinary set of circumstances to be involved with. So thank you very much. And also the workshop that we went on that was called Atmospheric Feedback Loops, and having a group of scientists very generously open up their research facility to a group of sort of 15 people that they don't know with a kind of wide range of interests, and see what are the ways in which we might think and work together. Now, in my presentation, Rosa asked me to sort of dip into my archive, my research archive, and to narrate that in some way. That is to say, my archive as a practicing artist. And so that's what I'm going to do today. I'm going to take the time to tell two stories. And they're stories, it's material that I'm going to narrate, some of which comes, cycles way back to sort of a kind of decade ago and marks an early point in a set of kind of interests around political violence, state surveillance, and then, but I'm going to begin with the more contemporary story, which is the story of U-235 and Uranium-235, precisely because that's a project I'm working on right now, which is a video trilogy that in some way gathers together a long-term set of research interests around nuclear materiality, and specifically the provocation of evidence, because evidence for events often secretes itself in matters in ways that is not immediately kind of perceptible or discernible, so you require certain kind of techno-scientific probes to kind of access type of history. And that's really the story that I unpack in my material witness kind of project, what are the ways in which materials themselves register kind of trace evidence, say, of the violence out of which they emerged. And that's an interest that, although I'm not going to present today per se, but I think it really raises really important sort of questions for me, and some of them came out in our workshop yesterday, which is what happens when evidence for events in some way is largely operating beyond the threshold of human kind of perception. So we understand that when it comes to say, data analytics, algorithms, high-frequency trading, et cetera, et cetera. So these two stories deal with certain kind of material artifacts in relationship to evidence, but I think they're trying to open up a wider set of questions around the ways in which we might interface with a world in which events increasingly are operating beyond, not just beyond the thresholds of human perception, but are organized by a certain kind of technical infrastructure in which the human has a kind of perhaps a minimal role to play. So I will begin. So the presentation is called Disappearing Evidence, and there are two cases. And my research practice as an artist involves a kind of investigative impulse to kind of investigate certain conditions and reflect upon them vis-a-vis the sort of our contemporary kind of political moment. So that's, okay. So I would, oh, actually one other thing I would just like to signal, which is as an artist, I'm also trying to always, which I say this just also in relationship to Sally Jane's introduction, which is I'm always looking for what are the kind of appropriate languages by which we translate our research, because oftentimes I might be working with a team of kind of prosecutors in which the ways in which we develop evidence has to abide by certain very kind of specific kind of protocols that aren't necessarily amenable for producing a kind of an aesthetic encounter, say, within the context of a gallery. So it's also translation of research and between different, not just kind of disciplines, but different modes of kind of practice and thinking are sort of key to my practice. So, but today I'm going to assume the kind of mode of a kind of storyteller and maybe a detective. In May 1972, a scientist working at a nuclear fuel processing plant in France ran a series of standard tests on depleted uranium samples recovered from ore mined at Okla in the Franceville Basin of Gabon in West Africa. The results of this routine analysis proved strangely perplexing and revealed a lower than expected level of the isotope U-235, the crucial atomic ingredient for sustaining a nuclear reaction. Uranium-235 is one of the three primary isotopes found in the Earth's natural uranium reserves, each of which is characterized by a different atomic mass, with uranium-238 comprising 99.28% of the planet's total uranium isotopes, followed by uranium-235 and infinitesimal amounts of uranium-234 on rare occasions. Now, despite the changing chemistry of the planet over more than 4 billion years, the ratio between these naturally occurring uranium isotopes is thought to be consistent throughout the geology of our solar system, whether they are found in the Earth's crust, in meteorites that have broken free of asteroids, or in pilfered moon rocks. Although U-235 atoms make up less than 1% of the total isotope count of uranium, the disproportionate results evinced by Okla's ore, which disclosed a diminished mass of 0.6% or half the anticipated levels, troubled a science built upon the singular constancy of a fixed ratio between U-238 and U-235 isotopes. The slight depletion in the amount of uranium-235, combined with the presence of an excess of certain fission product isotopes, was enough to convince French nuclear scientists working at the French Atomic Energy Commission that the rocky material carried trace evidence of a radical new state of matter. Further analysis showed that the ore from at least one part of the mine was far short of uranium-235. Some 200 kilograms appeared to be missing, enough to make a half dozen or so nuclear bombs. So where did this missing radioactive material go? All radiological isotopes, whether found in nature or artificially manufactured, emit radiation at various rates of decay. With the case of uranium, the rate of radioactive decay varies between its three isotopes, such that U-235 decays at a much faster pace than its more ubiquitous companion, U-238. Therefore, the only viable scientific explanation that could account for the reduced mass of the Oklo samples was that the original percentage of uranium-235 atoms must have been much higher at one point, somewhere in the range of 3%, in order to arrive at its present state and yield such anomalous readings. Given that today a change in the natural ratio between these radioactive isotopes can only be artificially achieved by inducing a series of nuclear chain reactions, the French scientists who ran the tests in 1972 surmised that a nuclear reactor of some kind must therefore have existed at Oklo some 2 billion years ago. Indeed, the depleted atomic signature of the ore samples was astonishingly similar to the same percentages found in the spent fuel produced by the reactors of contemporary nuclear power plants. For the proportionate levels of radioactive decay to align themselves correctly with those observed in the depleted uranium extracted in Gabon, scientists would have to calculate backwards into the far distant past to the time at which the Oklo deposits first formed, approximately 1.7 billion years ago, and started their slow energetic burn. The conditions of early Earth were, of course, dramatically different than those present today, allowing uranium grains trapped in rock to dissolve and achieve sufficient concentrations for sustaining a nuclear reaction. Through processes of weathering, gravitational sorting, and enrichment, uranium materials would go critical in a unique oxygenated environment that no longer exists on Earth today. And a quote from one of the kind of landmark papers that emerged. Physicists confirmed the basic idea that natural fission reactions were responsible for the depletion in uranium-235 at Oklo quite soon after the anomalous uranium was discovered. Indisputable proof came from an examination of the new lighter elements created when a heavy nucleus is broken in two. The abundance of these fission products proved so high that no other conclusion could be drawn. A nuclear chain reaction, very much like the one that Enrico Fermi and his colleagues famously demonstrated in 1942, had certainly taken place, all on its own and some 2 billion years before. Radiological evidence in the form of a geological proof, 200 missing kilograms of uranium-235, corroborated the propositional fiction forwarded by American theoretical physicist George Wetherill in 1953 that self-sustaining nuclear reactors once raged across our planet. The discovery in West Africa, some 20 years later, would come to be known as the Oklo phenomena. Over time, 19 such ancient nuclear reactor zones were eventually to be found within the region, some revealing traces of even much larger reactor zones. The Oklo phenomena, as a radiological relic of the primordial time of early Earth, is surely the warning sign par excellence of the extreme temporality of our nuclear inheritance. Meteorology. Early Monday morning on April 28, 1986, Cliff Robertson was about to begin his shift at the Forsmark nuclear power station, having just finished his breakfast in the coffee room. When he passed through the plant's radiation detector, he set off its alarm, signaling the dangerous presence of radioactive contamination. After repeated attempts to enter, the alarm's warnings were finally silenced. Robinson hadn't yet been in the controlled area of the plant that day, so he assumed that the alarm was faulty, needing some minor adjustments. Robinson was employed as a chemist at Forsmark, one of Sweden's largest nuclear power plants, located just a couple of hours north of Stockholm on the country's east coast. His job was to monitor radioactivity throughout the power station. When he completed his rounds that morning, he returned to see a growing queue of workers waiting to pass the detector. Each time, the alarm would emit its seemingly temperamental caution. He says, no one could get through because the alarm kept going off. But realizing that something much more serious might be happening, Robinson grabbed a shoe worn by one of the waiting workers and placed it on the germanium detector in the lab. Quote, then I saw a sight I will never forget. The shoe was highly contaminated. I could see the spectrum rising up very quickly, and it was just amazing because there were many radioactive elements there that we normally don't see in the cooling water at Forsmark. I remember vaguely that I had some idea that perhaps a nuclear bomb had exploded somewhere. After alerting his superiors, Robinson was asked to inspect the plant's chimneys to determine whether a radiation leak was coming from Forsmark. By 11 a.m., further alarms sounded an evacuation order for the entire plant. Only key personnel involved in safety procedures remained behind, and Robinson was one of those who stayed to monitor for radioactivity. Nothing indicated any malfunction or problem at Forsmark, he says. It was just that the surroundings were very heavily contaminated. Testing of all of the 3 reactor blocks came back clean, suggesting that the source of the leak must be coming from outside the plant itself. When the Swedish Radiation Authority received notification from Forsmark later that morning, reporting unusually high levels of radiation, despite no evidence of any breakdown at the plant, concerns that an atmospheric release of radioactive isotopes had taken place somewhere were immediately raised, including the possibility of the detonation of a nuclear bomb. Soon, other Swedish plants were also reporting extremely high levels of radiation. Baffled, the authority began plotting reports of contamination in Sweden, reactor locations in the region, and charting wind patterns on a map. Soon, several Soviet nuclear power plants, including Chernobyl, started to emerge as a probable source. Indeed, initial speculation pointed to a Russian plant close to the Swedish border, given Chernobyl's considerable distance from Forsmark. The scale of the accident would have had to have been massive if radioactive isotopes originating from as far away as the Ukraine were to have migrated northwest to produce the levels of contamination reported in Scandinavia. Eventually, direct evidence in the form of a radiological fingerprint, cesium-137, would corroborate the growing suspicion that the contamination discovered at Forsmark could only have come from outside Sweden. Cesium-137 is a radioactive isotope that results from human activities alone, either that of a nuclear reactor or the detonation of an atomic bomb. It occurs spontaneously when much heavier elements, such as uranium and plutonium, absorb neutrons and undergo fission. Chemical testing at Forsmark revealed the presence of a radioactive isotope not native to those produced by its reactor, nor indeed by any of Sweden's other operational power plants. Despite the urgency of the situation, communiques with Moscow resulted in an unequivocal no when Swedish diplomats inquired as to whether a nuclear accident might have taken place somewhere on its soil.
На экране один из
Only when Sweden threatened to file an official alert with the International Atomic Energy Authority did the Soviet Union admit privately that there had been some sort of accident at Chernobyl. By noon on Monday, 42% of Forsmark's area residents had heard about events at the plant. By that same evening, 66% had been informed. In Pripyat, the city adjacent to Chernobyl, preparations were underway for May Day celebrations, so no word would be uttered publicly as to the extent of the radiological disaster that lurked directly within their midst for more than 19 days. In the crucial period following the explosion at Reactor Unit 4, silence on the part of the Soviet state would prove fatal, as emergency measures, such as the distribution of iodine tablets, which can absorb and neutralize radioactive isotopes, were not implemented. The material witness that would first come to testify publicly to the accident at Chernobyl was not to be found in the vicinity of the reactor, but on the soles of an engineer's shoes, located more than 1,100 kilometers away from the scene of the crime. Today, any database search engine will return the nuclear accident at Chernobyl when the date April 26, 1986 is input into its search parameters, whereas a microfiche review of Soviet newspapers such as Pravda and Izvestia from the same period reveals a time lag of 19 days before the event registered publicly in print that a major nuclear accident had taken place. Although an orbiting American satellite took nighttime images of the reactor explosion, and scientists and meteorologists outside of the Soviet Union recorded extraordinarily high levels of radioactivity within days of the meltdown, this information was not publicly acknowledged as pertaining to Chernobyl for almost 3 weeks, since Mikhail Gorbachev and the Central Committee largely withheld news of the disaster. On April 29th, in response to rapidly growing rumors circulating outside of the Soviet Union that something had happened at Chernobyl, did Gorbachev deign to place a series of discreet notifications with the 5 news agencies indicating that a minor incident had occurred at Chernobyl. Quote, "An accident occurred at the nuclear power plant in Chernobyl. One of the reactors has been damaged. Measures have been taken. A governmental commission is inquiring," end quote. In reality, the accident at Chernobyl was massive, releasing higher levels of radioactive contaminants into the environment than any preceding radiological event, whether the detonation of 2 atomic bombs over Hiroshima and Nagasaki in 1945, the fallout from atmospheric nuclear weapons testings in the years 1952 to 63, the explosion at Mayak, or the partial reactor core meltdown at 3 Mile Island in the United States in 1979. By severely underplaying the gravity of the situation, tragically delaying reports that a substantial nuclear explosion had taken place, and downplaying the potential for contamination, a tragedy of far greater consequences ensued. For those working at the Chernobyl nuclear power plant or living in the adjacent city of Pripyat, this time lag would prove fatal as malignant cells metastasized, seeding their defects throughout the zone, and eventually airlifting their malevolence across the borders of the Ukraine into Belarus and Europe. Despite this interval in public disclosure, evidence of an immense release of airborne radioactive contaminants was already being carried from the USSR across Belarus and Poland to settle throughout northern Sweden, where it was absorbed into surface water, groundwater, biota, and soil. Cesium-137 is one of the most challenging short to medium-term fission products because it is highly soluble in water and thus able to move and spread easily in natural environments. A dangerous arrangement of nuclear matter composed of 82 neutrons and 55 protons would disclose a unique radiological identifier known as cesium-137 that could be traced directly back to its source in the Ukraine. Contrary to the homegrown chemistry of Forsmark's radioactive outputs, Chernobyl had unleashed billions of becquerels or units of radioactive material in the form of strontium, plutonium, iodine, and in particular, cesium-137, creating a trail of atmospheric evidence. Even invisible particles carried aloft by the wind or adrift on the ocean's currents can be made to speak and eventually testify to the disasters that spawn them. The fact of their unique anthropogenic origins distinguishing them from other naturally occurring radiological elements. I'm going to come to a close with this case, hydrology. On February 19th, 2015, so almost exactly a year ago now, or just over a year ago, water samples taken off the coast of Ucluelet, a historically indigenous community located on Vancouver Island, revealed for the first time ever trace evidence of the radioactive isotopes of cesium-134 as well as cesium-137. The levels detected were extremely low and far less concentrated than the dose of radiation we annually receive from exposure to natural background radiation, or indeed the everyday levels of radiation we encounter when using a mobile phone, traveling by airplane, smoking, or undergoing routine dental x-rays. Yet the scientists at Woods Hole Oceanographic Institution in the US who tested the water samples from Ucluelet said that they could only have come from one source, the nuclear accident at Fukushima, which had taken place 4 years previously in March 2011, when a tsunami and earthquake colluded to wreak havoc on the eastern shores of Honshu Island. While Chernobyl's fallout would eventually spread across extensive tracts of arable land in Europe, Fukushima's contamination seems to have traveled further still, crossing some 7,600 kilometers through the vast microbial channels of the Pacific to reach the western shores of British Columbia 4 years later.
Traces of radioactivity from the nuclear accident in Japan 4 years ago have washed up on Canada's coastline. It's the first time they've detected materials from the accident in North America, but they say the amounts don't pose a threat to living creatures. Scientists at the Woods Hole Oceanographic Institution tested samples of seawater collected in Ucluelet, British Columbia, 2 months ago. They found traces of cesium-134. They say the levels were 1.4 becquerels per cubic meter, well below the internationally set level at which human and marine life can be affected. Cesium-134 is produced only by human activity. The scientists say the Fukushima Daiichi nuclear plant has been the only place where the material has been released in recent years. The team has been collecting samples from along the North American coast for more than a year. They'd previously detected radioactive materials offshore, but not along any beaches. Researchers expect to find detectable levels of cesium-134 in other areas in the coming months, and they say they will keep monitoring the situation.
So yeah, she neglects to mention it's cesium-134 and cesium-137. So cesium-137 did in fact make its first appearance in the early solar system through processes of natural nuclear fission, such as that which occurred at Oaklow. But more than 1.7 billion years would pass before it reappeared on planet Earth in any detectable amount, this time on December 2nd, 1942, as a result of a chain reaction produced by the first ever human-made nuclear reactor, the Chicago Pile 1, built under the supervision of Fermi. But in the following decades, humanity began to significantly change the global radiation environment by testing nuclear weapons in the atmosphere. By the early 1960s, there was no place on Earth where the signature of atmospheric nuclear testing could not be found in soil, water, and even polar ice. According to the disclosures made by TEPCO, the company that owns and operates 17 of Japan's 54 nuclear power plants, including the Fukushima Daiichi plant, at least 2 trillion becquerels were released in the Pacific Ocean between August 2013 and May 2014 alone. Today, irradiated debris and contaminants from the damaged plant is still being discharged into the coastal waters off Japan's eastern shore. In deliberate efforts to diffuse and slow down the rate at which radioactivity builds up ever more lethal concentrations in the groundwater around the Fukushima plant, TEPCO continues a program of intermittent release of radioactive materials into the ocean. Water samples taken off the coast of Japan during the immediate aftermath of the accident registered the presence of extraordinarily high levels of radioactive isotopes. By the time the ocean currents had carried the contaminants across the Pacific to the coast of British Columbia, hydrological dispersal had reduced the concentrations to 1.4 becquerels per cubic meter from 50 million, which was what the reading was, which showed directly on the outside of the Fukushima Daiichi plant in the Pacific. According to Canada's Department of Fisheries and Oceans, the Pacific Ocean typically contains cesium-137 levels of only about 1 becquerel per cubic meter. So this makes the kind of levels near Eucalypt 6 times higher than the kind of standard levels of radioactive contaminants or presence. So Spatial and temporal dispersion, however, doesn't diminish responsibility, nor indeed hide the culprit from the crime. We really know very little about the long-term cumulative health effects of radiation exposure over millennia. Just as July 16th, 1945, with the explosion of the first nuclear weapon, which was the explosion of the first nuclear weapon, the Trinity test, just as July 16th, 1945 irrevocably altered the planet's baseline radiation as naturally occurring cosmic and terrestrial radiation was supplemented by newly created forms of anthropogenic radioactive isotopes, scientists at Woods Hole Oceanographic Institution remain cautious and don't diminish the significance of their measurements taken off of British Columbia's coast. Quote, radioactivity can be dangerous and we should be carefully monitoring the oceans after what has certainly been the largest accidental release of radioactive contaminants to the oceans in history. And I'm actually from British Columbia, and anyway, I can talk a little bit more about my plans to spend some of the summer back in the area around Eucalypt. But in Nootka, which is the indigenous language of that region of the west side of Vancouver Island, the word Eucalypt, which is actually the name of the community, or Eucalypt or Eucalypt, there's a kind of, however it gets pronounced, Eucalypt translates actually in Nootka as people of the safe harbor. In sketching out the geological, meteorological, and hydrological appearance of nuclear evidence secreted within the molecular arrangement of matter, I wish to reestablish a version of Locard's exchange principle. And Locard was the considered the sort of father or pioneer of modern forensic science, and was responsible for introducing kind of new sort of techniques in the pursuit of kind of criminology. So the Lacorde exchange principle insists that every contact leaves a trace, regardless of the scale and duration of nuclear events, that suggests cause and effect are incontrovertibly pulled apart. Within climate justice work, the problem of proving direct causality between polluters and damaged ecosystems or health-related effects has itself proved a useful legal loophole to avoid paying out claims for compensatory damages or ceasing to engage in harmful activities. When the legal demand for such demonstrable proofs that one must be able to establish the incontrovertible relationship between cause and effect or direct evidence, when the juridical requirement is recast as a political demand, justice will always be disabled, even as many work hard to reestablish such causal relations. This condition of determinacy, which is often attributable to a certain condition of latency within material, so that is the kind of delayed, the delay in which certain kinds of the evidential registration doesn't actually necessarily disclose itself at the time of an encounter, which would be the case with the ways in which tumors develop from, say, exposure to radiation. So this condition of determinacy has allowed global climate change actors such as oil and gas to operate with virtual impunity. Inasmuch as charges of criminal liability must meet the condition of direct causality in order to achieve success in litigation, I would argue that the political too must take on the project of causality as one of its primary tasks, namely to reconnect the links that large-scale planetary phenomena has seemingly torn asunder. Certainly, this is already part of contemporary activist strategies, but the slow violence that often characterizes these kinds of events or underpins the longue durée of their evolution is less amenable to media mobilization and humanitarian intervention than the kinetic violence of military conflict and war. The struggle for justice in the post-Soviet nuclear environment offers a case in point, as long-term health risks and ongoing fatalities directly attributable to Chernobyl and its radiological aftermath are still hotly contested. It is the very lack of direct causal connections between the event and the slow release and accretion of its harmful effects that renders its political stakes all the more urgent. But the nuclear isn't exactly like so many other contemporary threats, which operate according to complex, nonlinear modes of causation, such as global pandemics, environmental hazards, counterinsurgency, and war. The kind of terror that Brian Masumi describes in his latest book, Ontopower, as an ultimately untraceable, nonlinear microflow that self-amplifies across the planet. Strangely enough, even highly dispersed evidence of nuclear events is often directly traceable back to its source, as is the case with the appearance of cesium-137 in Forsmark and Eucalypt. The unique chemical properties and behavior, that is to say the decay rates, of artificially produced radioactive isotopes leave trace of evidence of events behind them, even when this evidence is radically delocalized. Of course, the fact of their evidential appearance doesn't translate into a convincing narrative of responsibility without considerable work to corroborate the particular risks related to levels of exposure and concentration of dosage. Now, it's Rosa, how are we doing for time? So maybe I will dip into my other case and I will just cut it off when needed so we have time for questions. So, or I might try and do some editing on the fly. This is a very different case, but it might give you a little bit of insight in the ways that I try and put things together, and eventually they go out into the world as different kinds of things, as different sorts of projects or provocations. So tape 342. At some point during the evening of June 20th, 1972, we're back in the 70s again, a conversation between two men was secretly taped on a Sony reel-to-reel voice recorder, an innocuous machine that uses 5mm tape and was set to run at an irregular speed of 15/16 or half the rate of a standard tape recorder. In keeping with the low-fidelity recording mode, the tiny lavalier microphones that picked up this particular conversation were cheap and poorly distributed throughout the space. The result was a tape of degraded sound quality produced under deficient recording conditions. Tape 342, as it is officially referred to, is but one of a sprawling archive of approximately 3,700 hours of audio recordings taped surreptitiously by the late American President Richard Nixon over a period of several years. Known as the Nixon White House tapes, these recordings detail conversations between the president, his staff, and visitors to the White House in Camp David. Of the many thousands of audio tapes confiscated from the Oval Office, tape 342 remains by far the most infamous, not because of the damaging or volatile nature of the information it contains, but precisely because of its absence. A gap in the tape of 18.5 minutes. And I will just play you this, I'll play you this soundless sound, or what is, I'm going to play you a clip from the 18.5 minute gap. The location of the gap within the tape occurs during a conversation between Nixon and his White House Chief of Staff, H.R. Haldeman, 3 days after the break-in at Democratic National Committee headquarters in the Watergate Hotel. The date of their conversation and the proximity of the tape gap to the timeline of criminal events at the Watergate Hotel have led many to speculate that the tape must have contained highly damaging evidence. The American Bill of Rights, under the aegis of the Fifth Amendment, gives one the right not to speak on the grounds that such speech might implicate oneself in activities that are punishable by law, but it does not, however, allow one to take back or erase something already spoken. The absent recording had, in effect, converted non-evidence into such compelling and incriminatory material proof, a willful destruction of evidence, that moves towards presidential impeachment were in part activated. These are the microphones that Nixon had, so they're chapsticks that were modified into microphones, and they were distributed around the Oval Office. So, knowledge of the White House taping system installed by the Secret Service in 1971 first came to the public's attention during the testimony of former presidential aide Alexander Butterfield before the Senate Watergate Committee in July 1973. Less than a week after Butterfield's revelations as to the kind of the sort of complete kind of the audio setup in the Oval Office, Nixon ordered an end to White House taping, although the actual recording equipment was not removed until after he resigned in August 1974. Upon learning about the existence of the White House taping system, the Senate committee ordered all tapes considered relevant to Watergate to be turned over. Nixon refused, claiming executive privilege. By August, the matter was in court. Nixon addressed the nation on August 15, 1973, explaining to the people why confidential conversations between the president and his advisors should not be made a matter of public record. Lawyers for the Watergate Committee and Special Prosecutor's Office argued that conversations dealing with matters of potential illegality should not be suppressed by claims of executive privilege. Changing definitions of silence were central to shaping both the public perception of Watergate and the ways in which the prosecution developed their arguments. During the initial stages of the Watergate investigation, the existence of the White House taping system was not known, and therefore Nixon's refusal to speak on the grounds that his testimony might incriminate him marked his body as the initial locus of silence. When the discovery of the White House taping system was made public, and with it the existence of the vast tape archive, the U.S. Circuit Court of Appeals in Washington ruled that Nixon must turn over the tapes to presiding Judge Sirka. Nixon countered with an offer to provide edited transcripts of the tape, which were woefully inadequate. Nixon's personal secretary, Rosemary Woods, as a matter of course, in fact, she actually transcribed all of these secret kind of recordings. Maybe I'll continue a little bit more. In Nixon's follow-up State of the Union address, he insisted that the prosecutor had been given all the materials that he needs. However, the reluctant cooperation of the executive office did not result in the handover of any materials relating to the dates in question around the Watergate break-in. As public criticism mounted, including calls for impeachment, Nixon eventually relented and agreed to surrender most of the missing tapes. Although the White House always claimed that certain tapes subject to the subpoena did not actually exist. As the grand jury proceedings unfolded, silence consequently shifted from the aphasiatic body of the president to the absence of the subpoenaed tapes, and upon their recovery to the 18.5-minute tape gap in tape 342 itself. Through this sequence of juridical displacements, silence was reconfigured as the very means by which material artifacts could begin to speak for themselves. Although Nixon would continue to maintain his resolute silence, the tapes, including the gap, could now testify in his place. Once evidentiary silence was relocated to the tapes, Nixon's live testimony became largely irrelevant, as he was already literally on the record. Moreover, the series of clicking noises distributed through the 18.5-minute tape gap, so we heard a little bit at the beginning, so this series of clicking noises that were distributed through the gap offered circumstantial evidence that a process of clumsy erasure had occurred, raising the possibility that this machine silence was a consequence of a deliberate act. Controlling the discourse around silence proved to be a decisive strategy in turning the tide against Nixon in favor of the opposition. And there we have congressmen listening to the kind of Watergate tapes, et cetera, et cetera. Next to a man's wife, his secretary is the most important person in his career. She has to understand every detail of the job, to have unquestioning loyalty and absolute discretion. On every count, Rose measures up. I'm a lucky man. When news of the tape's potential tampering was made public, five minutes? When news of the tape's potential tampering was made public, Nixon's personal secretary, Rosemary Woods, who's now deceased, she made two rather contradictory public statements. In her court testimony of November 8th, 1973, she asserted her secretarial competency, flatly denying ever making any stupid transcription errors when handling the tape. The button said on and off, forward and backward. I caught onto that fairly fast. I don't think I'm so stupid as to erase what's on a tape. However, a month later, under cross-examination in a federal courtroom, she told a rather confused story of, in fact, how she might have made a terrible mistake and been partially responsible for the glitch. Rose claimed that while she was transcribing the tape on her Uhr 5000 tape recorder, the telephone suddenly rang, causing her foot to press the wrong pedal, thus producing the erasure. And this is a very interesting photograph because this is Rosemary Woods reenacting what she might have done. So I've always argued that this is actually the original staging of the performance. It's absolutely not a reenactment. And so it actually became known as the Rosemary Stretch, this sort of very kind of this sort of famous move. And of course, in the etymology of the word secretary also actually means the kind of keeper of the secrets. And this is various So once again, we have the kind of loyal secretary that has to take the fall, of course, for the sort of like the misdeeds of the patriarch. So not content to let the gap stand as circumstantial evidence in relationship to a crime, the prosecutor sought direct evidence of Nixon's involvement in the Watergate break-in. And so, in December 1973, tape 342 was escorted by 6 fully armed U.S. Marshals to the Federal Scientific Corporation in Harlem for testing. There, the tape was met by another 6 court-appointed technical experts and an advisory panel of engineers and electronics specialists entrusted with the forensic task of reviving the tape and bringing its latent speech acts back to life. Together, they carried out 200 hours of testing using spectrum and waveform analysis, digital signal processing, which was an emerging technology at the time, in addition to the optical inspection of magnetic particles made visible by washing the tapes in a fluid containing ferrite particles. And actually, I was able to obtain a copy from the National Archives of the 18.5-minute gap, which actually was no easy feat because they kept sending me the conversations on the other side of that, and I said I would like a copy of the silence, not the conversations that bracket the silence. So we had quite a long kind of back and forth. The tape was only ever the tape 342 was only ever played 6 times upon its discovery. So a copy was made right away, and then the tape was put away. So in fact, what they sent me was a copy of a copy. But I decided, I thought, as an interesting kind of project, I decided to produce my own kind of test and use the same kind of magnetic developer. And I was just writing a short piece for Cabinet magazine at the time. So these are just my work with the magnetic developer. And then another kind of technique that they used was to submit the tape to the scanning tunneling kind of microscope. And there we have another example of what the magnetic tape looks like under that kind of technology, which I was able to do at Imperial College in London, where they have a nanotechnology lab. So although the tape defied all technical efforts at conjuring its sound ghosts, it was understood as harboring important trace evidence that might testify to Nixon's criminality in the Watergate break-in. Fear of disturbing the remaining few magnetic particles that clung to the gap meant that after its initial testing, tape 342 was sealed and deposited into the vaults of the U.S. National Archives There it has lain in undisturbed cryogenic sleep for over 30 years, waiting for that moment when the kiss of technological progress will reawaken it. The archive leverages the partial erasure of tape 342 against the projected forensics of the future, wagering that further developments in technology will restore its lost speech acts. I think I will just, I'm not going to, these are just some images from the actual technical report. I'm just going to go through those super quickly. I'm jumping ahead. Yeah. In 2001, the National Archives reconvened a scientific panel to evaluate whether forensic audio technology had advanced sufficiently to consider unsealing tape 342 and resubmitting it to new modes of examination. Several unsuccessful proof-of-concept exercises were conducted using test reels recorded on the original Nixon-era tape recorders over a period of 2 years. 5 expert groups participated in this round of testing, which consisted of 2 test tapes recorded on the original Nixon White House Sony and then raced on Nixon's Secretary Rosemary Woods Ewer, so the tapes were recorded on a Sony, but then she transcribed them on the Ewer. So they made test tapes using both of these original tape recorders. John W. Carlin, chief archivist, John W. Carlin, chief archivist, attributed the failure in this new round of testing to the lack of suitable forensic technology. I'm fully satisfied that we've explored all of the avenues to attempt to recover the sound on this tape. The candidates were highly qualified and used the latest technology in their pursuit. We will continue to preserve the tape in the hopes that later generations can again try to recover this vital piece of our history. Yeah. A few years ago, I actually decided to track down the same test copies of tape 342 produced by the National Archives. So I contacted Paul Ginsberg, who's seen there in the kind of image, and he was one of the forensic audio experts who participated in the proof of concept exercises. Ginsberg, of course, reminded me that tape 342 had never been unsealed again for this purpose, and that NARA had made test tapes using similar recorders. It had not, in fact, made a copy of the tape, because in order to assess the relative success of any recorded audio materials, the National Archives would have had to know what was originally on the tape in order to understand whether any of the proof of concept tests could in fact recover the tape. So I've often wondered what was it that the National Archives actually recorded on these kind of test tapes that they sent out for forensic kind of testing, but no one seems to know the answer to that question. Because I'm going to wrap up actually, I think. Sorry?
There's 15 more minutes.
Before Q&A?
If you want.
Oh, okay, well, I'm jumping around a bit, and I think that's better okay. Apologies. Because the discourse around the tape has turned on the rhetorical deficiency of the gap, whether named as a silence or as an erasure that produced a breach in the historical record, my interest has always been to assert that a surplus of information now populates this gap, literally and conceptually. Although the National Archives' commitment to investigating the magnetic encodings of the tape and unlocking its secrets is tied to its conviction in technology's progressive futurity, the tape's status as mute has already been extensively undone by the sheer volume of speculation around what kind of lurid data lurks within. Musings that far exceed what any one man can actually say in 18.5 minutes. It is this conception of the gap as producing an excess, what Derrida has actually called, following Rousseau, Derrida might have called this a dangerous supplement. So regardless of how we might make sense of this surplus that continues to propel my interest in this media artifact. So what interested me, of course, in this erasure was that all of the speculation of what might have actually been said in there far exceeds, as I said, what actually, of course, could actually be said in 18.5 minutes. But moreover, when one understands the way in which the mechanical operations of a tape recorder, and this was very interesting in the court, because people kept talking about pushing the erase button on the tape recorder, but there is no erase button on a tape recorder. But yet, this is the way the ways in which the tape was discussed within the kind of juridical environment was always in terms of erasure. But if you actually know how an analog tape recorder actually works, you know that any erasure is only the consequence of a re-recording of kind of soundless sound. So it's not a subtractive process, it's actually an additive process. And I think this is an important kind of conceptual understanding that one only comes to through a kind of more empirical or investigation of the tape recorder. So I'm just going to finish this case study here and then maybe have one sort of make a few final kind of concluding remarks. So I contend that the tape gap is now, in its state of archival deep freeze, is much more resonant with acoustic potential than it was at the time of its original voice recording in 1972. Tape 342 need not look to future forensic operations to extort a testimonial from its lingering magnetic tailings, for the recorded material and subsequent erasure already speaks to us in many complex ways and on many different registers. Nixon's act of erasure, rather than destroying the sonic transmissions of the tape, radically reinvents the tape, renewing its orality so that it now speaks a kind of machinic glossolalia. In the end, the evidentiary value of the recorded tape is that of noise, which stands in the place of legible speech. So in unpacking these two particular cases, what I really wanted to do, I wanted to sort of think with you and through you, through questions of material evidence. Think about the changing scales of perception and detection, both the kind of deep time of anthropogenic violence, but also the kind of near time of political violence. And to perhaps think about what forms of action or intervention, based upon an ethics not just of visibility, but of duration, what I might call a kind of politics of the remainder. So what kinds of forms of action and intervention can we actually imagine in relationship to changing scales of perception? What new kinds of practices and modes of political engagement must we develop when evidence for events falls entirely outside the register of human perception and increasingly requires the intercession of a techno-scientific apparatus to render it sufficiently legible, such that we can interrogate its truth claims and make or recalibrate our demands for accountability and perhaps even justice? This will require much greater participation in the epistemological frameworks that currently organize and manage these techno-scientific assemblages, and that may be a formidable challenge for us all. And so I think I would like to leave it there and then open up for kind of questions. So thank you.